All right, so get this. You want to like really get a grip on how huge the Milky Way actually is.
Huge is an understatement.
I know, right? We're talking distances so massive that even like the fastest thing we know of takes thousands of years to cross it. It's mind-blowing.
It really is.
But the cool thing is you sent us some sources that use some really creative ways to explain it all.
Yeah, some great analogies to make these mind-boggling scales, well, a little more down to earth.
Exactly. So we're going to start off right here in our little corner of the universe, the solar system.
Right in our cosmic neighborhood.
And then we're going to zoom out, like way out, further than you can imagine.
Much further. It's going to be a wild ride.
So to kick things off, let's talk about the distance to the moon. 384,400 kilometers.
Yeah, that's something we can kind of wrap our heads around. It's a good starting point for understanding these intergalactic distances.
Okay, but 384,400 kilometers, that's got to be like, what, a few days in a rocket? You think they had those little airplane snacks on board?
Well, if we were talking about like a regular commercial airliner cruising at, say, 1,000 kilometers an hour, it would actually take around 16 days to get to the moon.
16 days, nonstop, in an airplane seat.
Nonstop.
Oh, man, I can't even imagine. And wouldn't that make communication a nightmare, like a super delayed text message or something?
Even at the speed of light, which is like the fastest speed possible, a round-trip message to the moon takes about 2.5 seconds.
It's pretty wild when you think about it.
Yeah, it's a noticeable lag for sure, especially if you're trying to control a rover or have a real-time conversation.
Right. Imagine trying to have a phone call with someone on the moon. Hey, can you hear me now? 2.5 seconds later. Yeah, you can hear you. It would be impossible. So even a short hop like going to the moon presents some pretty serious communication challenges. What happens when we start talking about missions to Mars, which at its closest is 56 million kilometers away?
Mars. Now we're talking about a serious commute. That same airplane trip to Mars would take about 6.2 years. And that's just one way.
6 years. You'd practically be a Martian by the time you got there. I can't even keep a houseplant alive for 6 months.
And the communication delays would be a whole other issue. A round-trip message to Mars at the speed of light would take at least 6 minutes. Forget about instant messaging. We'd be back in the days of letter writing.
This is making me really appreciate the instant connectivity we have here on Earth. It's pretty amazing when you think about it.
Yeah.
But while we're talking distances, you mentioned Mars being closest to Earth. Isn't that distance always changing?
You're absolutely right. The distance between planets is constantly changing because of their orbits.
It's like a cosmic dance.
Exactly. And it's not just Earth and Mars. Even the distance between the Earth and the Sun, which we define as 1 astronomical unit, or AU, is an average because it fluctuates throughout the year.
Right. Because Earth's orbit isn't a perfect circle, it's more of an oval shape, right? And that's why we have those fancy terms like perihelion and aphelion, the closest and farthest points in Earth's orbit around the sun.
You go.
But if it's the shape of Earth's orbit, not the distance that causes the seasons, what's the significance of this changing distance to the sun?
It highlights a really important point about orbits. They're not static. The planets are constantly moving in relation to each other and to the sun. And this kind of cosmic dance has big implications for everything from the length of our year to the potential for space travel.
So it's all connected. Okay, so we've gone from a 16-day flight to the moon to a 6-year haul to Mars, and even that's just a tiny step in our journey. What happens when we venture out to the edge of our solar system? Neptune, for instance, is roughly 30 AU from the sun. That's like 4.5 billion kilometers.
Yeah, to give you an idea of just how mind-boggling that distance is, let's go back to our airplane analogy. A flight to Neptune would take roughly 490 years.
490 years. That's longer than the United States has even existed. And to think it takes sunlight traveling at the speed of light over 4 hours to reach Neptune. But even Neptune isn't the absolute edge, is it?
You're thinking of the heliopause. It's the boundary where the sun's influence fades and interstellar space begins. Imagine it like this giant bubble surrounding our solar system, kind of like a cosmic fence marking the transition to the vast, uncharted territory between the stars.
So we've crossed the solar system, ventured past the heliopause, and now we're truly in interstellar space. What's our next landmark on this cosmic road trip?
Well, if we're talking about landmarks, our nearest stellar neighbor is Proxima Centauri. It's a red dwarf star about 4.24 light years away.
Okay.
That translates to roughly 40 trillion kilometers, or a mind-blowing 270,000 AU.
Whoa, we've jumped from billions to trillions. That's a lot of zeros. But if that's the closest star, just imagine the distances between other stars scattered throughout the Milky Way.
The average distance between stars in the Milky Way is estimated to be about 16,000 AU. To put that into perspective, imagine our solar system shrunk down to the size of a coin. The next nearest star system would be about 40 kilometers away.
So even though the Milky Way is teeming with stars, it's mostly empty space. I guess it really is the final frontier.
This makes me wonder about stars that are much larger than our sun. We talked about Betelgeuse earlier, that red supergent star, which is a mind-boggling 700 times larger than our sun.
Betelgeuse is a truly colossal star. If it were in the center of our solar system, it would engulf Jupiter's orbit.
I read that if every human who ever lived walked their entire lifetime distance, all of us combined would barely reach Betelgeuse. That's just incomprehensible.
And here's the kicker. Betelgeuse, as gigantic as it is, represents less than 1% of the Milky Way's total size.
Less than 1%. That's like comparing a grain of sand to an entire beach. Okay, so we've gone from the moon to Mars, ventured to the edge of the solar system, and even glanced at the gargantuan Betelgeuse. Now we got to tackle the Milky Way itself, a galaxy spanning 100,000 light years across. How do we even begin to visualize that?
Well, that's where things get really interesting. Let's try shrinking it down a lot.
Shrinking the Milky Way. Now that sounds like a challenge even for the most powerful shrink ray. Imagine this. The entire Milky Way galaxy, with its hundreds of billions of stars and vast stretches of interstellar space, shrunk down to the size of Earth.
The entire Milky Way shrunk to the size of Earth. I can't even. How much smaller would that make everything?
We're talking about a reduction of 74 trillion times. It's almost impossible to grasp. But in this scaled-down model, our sun, which we think of as this giant life-giving star, would be thinner than a human hair.
So if our sun is a tiny hair, what happens to Proxima Centauri, our nearest neighbor, in this shrunken Milky Way?
Proxima Centauri in this scaled-down model would be about half a kilometer away from our hair-thin sun. And Betelgeuse, that supergiant we talked about, it would be about 80 kilometers away.
So even though everything is shrunk down to almost unimaginable scales, the relative distances are still maintained. That's a pretty neat way to visualize it. It really highlights the vastness of even our own galaxy.
And here's another mind-blowing fact. The light we see from stars on the opposite side of the Milky Way left those stars when early humans were just starting to walk the Earth.
Wow. So we're not just looking across space, we're looking back in time.
I need a minute to process all of this.
Take your time. It's a lot to absorb. It's a pretty profound concept when you think about it. The idea that when we look at the stars, we're actually peering into the past.
It really makes you realize that the universe isn't just like this static backdrop. You know, it's like this dynamic, ever-evolving thing, a tapestry of events unfolding across like vast stretches of space at a time.
Exactly. And speaking of vast stretches, remember that shrunken Milky Way we were picturing?
Mm-hmm.
The one scaled down to the size of Earth? Let's zoom out even further. Beyond the edges of our miniature galaxy.
Okay.
What we'd encounter out there is a truly humbling sight, a realm teeming with other galaxies.
Wait, other galaxies, not just stars and planets, but entire galaxies like our own, each with their own billions or even trillions of stars.
Precisely. Each galaxy is like its own island universe,
Wow.
a vast collection of stars, gas dust planets, all bound together by gravity.
Wow. And here's where things get really mind-boggling. Astronomers estimate that there are trillions of galaxies in the observable universe.
Trillions. That's like saying there are trillions of grains of sand on all the beaches on Earth. I can't even fathom a number that big.
It's a pretty humbling realization, isn't it? But let's try to make it a little more concrete. In our scaled-down model, where the Milky Way is the size of Earth, the distance to the nearest major galaxy, Andromeda, would be about the actual distance between the Earth and the Moon.
So if I walked outside tonight and looked up at the moon, that's how far away the nearest major galaxy would be. If the entire Milky Way were shrunk down to the size of Earth, wow, that really puts things into perspective. And to think that's just one galaxy out of trillions.
It's a mind-boggling concept. And remember, we're only talking about the observable universe, the portion we can see from Earth with our current technology. There might be countless more galaxies beyond that hidden from our view.
It's like we're standing on the shore of a vast cosmic ocean, and we've only dipped our toes in the water. What other incredible wonders lie beneath the surface, waiting to be discovered?
That's the beauty of scientific exploration. There's always more to learn, more to discover, more to ponder. And sometimes those discoveries lead us to even deeper mysteries.
Like dark matter. I know it's one of the biggest puzzles in astrophysics, but to be honest, I'm still a bit fuzzy on what it actually is.
Dark matter is a fascinating enigma. It's this mysterious substance that doesn't interact with light, so we can't see it directly.
Okay.
But we know it exists because of its gravitational effects on visible matter, like stars and galaxies.
So it's like a cosmic ghost, exerting its influence on the universe but remaining hidden from our view.
That's a great way to put it. Imagine a giant spider web holding galaxies together in clusters and influencing their movements.
Okay.
We can see the threads of the web, the visible matter, but we can't see the spider itself, the dark matter that's holding it all together.
Whoa, that's a chillingly accurate analogy. So just how much of the universe is made up of this elusive dark matter?
Scientists estimate that dark matter makes up a staggering 85% of the total matter in the universe.
85%. So that means all the stars, planets, galaxies, all the stuff we can see and interact with only makes up a tiny fraction of what's actually out there. The universe is playing a pretty epic game of hide and seek with us.
It certainly is, and it's a game that scientists are determined to win. They're using all sorts of incredibly sophisticated instruments, from underground detectors to space telescopes, to try to detect and understand dark matter. It's one of the most exciting frontiers in modern science. But it's not the only cosmic mystery that's keeping scientists up at night. We haven't even talked about dark energy yet.
Okay, so we've got dark matter, the invisible web holding the universe together, and now we've got dark energy. Is that like dark matter's mischievous cousin causing even more chaos?
You could say that. While dark matter pulls things together with its gravity, dark energy seems to be doing the opposite. It's pushing everything farther and further apart. It's actually thought to be responsible for the accelerating expansion of the universe.
Wait, hold on. The universe is expanding, but I thought it was already infinitely big. How can something that's already infinite get even bigger?
That's a great question, and it gets to the heart of how we understand the universe. When we say the universe is expanding, we're not talking about it growing outwards like a balloon inflating into a room.
Okay.
It's more like the fabric of space itself is stretching, carrying galaxies along for the ride.
So it's not about the universe expanding into something. It's about the space between things getting bigger. That's a pretty mind-bending concept.
It is indeed. Think of it like dots on a balloon. As you inflate the balloon, the dots get farther apart, but the balloon itself doesn't have an edge that's growing. It's the surface of the balloon that's expanding.
Okay, I think I'm starting to get it. So dark energy is like the breast that's inflating the balloon, causing the universe to expand faster and faster. But what exactly is dark energy? Is it some kind of mysterious energy field permeating all of space?
That's the million-dollar question. Scientists are working tirelessly to find the answer. We don't know for sure what dark energy is, but there are a few leading theories. Some scientists believe it's a property of space itself, a kind of energy inherent to the vacuum. Others think it might be a new kind of dynamic energy field or fluid that fills space.
So it's like we've stumbled upon a whole new realm of physics, and we're just beginning to explore its possibilities.
Exactly.
It's a bit daunting, but also incredibly exciting.
It really is. Every new observation, every new piece of data could potentially unlock the secrets of dark energy and revolutionize our understanding of the universe.
It's mind-boggling to think that the universe is so much more complex and mysterious than we ever imagined. We've gone from thinking about the vast distances between stars to grappling with these invisible forces that shape the very fabric of reality.
It's a humbling reminder that we're still at the very beginning of our cosmic journey. There's so much more to learn, so many more mysteries to unravel.
Well, you know what they say, the more you learn, the more you realize you don't know.
Right.
But that's what makes it all so fascinating, right? The quest for knowledge, the pursuit of understanding, that's what drives us to explore, to question, to push the boundaries of what we know.
I couldn't have said it better myself. The universe is an endless source of wonder and inspiration. And I, for one, can't wait to see what other secrets it reveals to us.
You know, it's funny how we can go from discussing like trillions of galaxies to feeling totally overwhelmed by the mysteries in our own little cosmic backyard.
Right.
It's like realizing you have this entire unexplored continent just sitting in your basement.
Yeah.
Speaking of mysterious backyards, what about black holes?
Black holes.
They seem to capture everyone's imagination, but I feel like very few people actually understand what they are.
Yeah, it's true. Black holes have this kind of mystique about them.
Yeah.
They're these regions of space-time where gravity is so incredibly strong that nothing, not even light, can escape.
That's crazy.
It's like, imagine a cosmic drain, but instead of water, it's swallowing up light and matter.
So they're like the ultimate cosmic vacuum cleaner.
Yeah.
But if they swallow up even light, how can we even know they're there? It's not like we can just point a telescope and be like, oh, look, there's a black hole.
That's the challenge with black holes. We can't observe them directly,
Okay.
but we can detect their presence by looking at how they affect nearby matter.
Oh.
Think of it like a whirlpool in a river. You can't see the whirlpool itself, but you can see how it makes the water swirl around it.
Right. So instead of water, we're looking for stars and gas swirling around this invisible gravitational monster.
Exactly. As matter gets pulled towards a black hole, it forms this swirling disk called an accretion disk.
Okay.
And that disk heats up to crazy high temperatures and starts emitting X-rays that we can detect with special telescopes.
So it's like a cosmic spotlight illuminating this hidden black hole.
That's a great way to put it.
That's pretty cool.
Yeah.
But black holes sound kind of terrifying. Are there any lurking near Earth that we should be worried about? Like, what if one suddenly decided to just swallow up our entire solar system?
Not to worry. The nearest known black hole is thousands of light years away from Earth. And they're not exactly like roaming around the universe randomly gobbling up everything in sight. Black holes are definitely fascinating, but they're not an immediate threat to our planet.
That's a relief. But speaking of mind-bending space stuff, what about wormholes? Are those a real thing, or are they just science fiction? Could we, like, someday use them as cosmic shortcuts to zip across the galaxy?
Wormholes are definitely more on the theoretical side. They're these hypothetical tunnels through space-time that could potentially connect distant points in the universe. Like a cosmic shortcut.
And that would be awesome.
I know, right?
So are scientists actively trying to, like, find these wormholes or create them?
So far, there's no observational evidence that they actually exist.
Oh, great.
They're still very much in the realm of speculation and mathematical models.
So no wormhole-powered spaceships anytime soon. Bummer.
Yeah.
But it's fun to imagine the possibilities. Okay, one last cosmic brain twister for you. The multiverse. Is there any scientific basis for the idea that there are multiple universes out there, each with its own set of physical laws and maybe even different versions of ourselves running around?
The idea of the multiverse is super intriguing.
I know, right?
It's captured the imaginations of physicists and science fiction writers for a long time. The concept actually comes from certain theories in physics, like string theory and inflationary cosmology. They suggest that our universe might just be one of many.
Whoa.
Maybe even an infinite number of universes all existing together.
So imagine infinite universes, each with its own unique properties, maybe even different versions of ourselves living out alternate realities. It's almost too much to comprehend. But is there any actual evidence for this, or is it just a mind-blowing theoretical concept?
It's important to remember that the multiverse is still a very speculative idea. There's no direct observational evidence to support its existence, and it's still a topic of ongoing debate and research among scientists. It's definitely a tantalizing possibility.
Totally.
And one that might remain a mystery for a long time to come.
Well, I guess some mysteries are best left unsolved.
Yeah.
At least for now. I think we've covered a lot of ground in this deep dive.
We have.
We started with the simple question, how big is our galaxy? And we ended up exploring concepts like dark matter, dark energy, black holes, wormholes, and even the mind-boggling possibility of a multiverse. It's been quite the journey.
It has. We've gone from the familiar scale of our solar system to the just incomprehensible vastness of the cosmos, encountering wonders and mysteries that really challenge our understanding of the universe.
And it's a great reminder that even though we've made these incredible strides in our scientific understanding, there's still so much we don't know. There are still countless questions waiting to be answered and countless wonders waiting to be discovered.
Absolutely. And that's what makes exploring the universe so captivating.
Yeah.
It's this never-ending journey of discovery, a quest for knowledge that will likely continue for as long as humans look up at the stars and wonder.
I couldn't agree more. So keep looking up, keep questioning, keep exploring, and never lose that sense of wonder. Who knows what amazing discoveries are waiting for us out there in the vast expanse of the cosmos.
Until next time, keep exploring.